One afternoon, a single company has a bad day. Somewhere in a control room, a routine change goes out to the network, the kind of change that ships hundreds of times a week and is never news. This time it is wrong in a small way, and the small way spreads. Within minutes, sites that have nothing to do with each other start flashing the same error page. A bank login, a coffee shop's order app, a government portal, a video game, a news homepage. None of them share an owner, none of them share a city, and yet they all break in the same second with the same blank message because underneath all of them was the same invisible company. Most people watching never learn its name. They assume the internet itself went down because from where they sit it did. Afternoons like that have happened more than once. Each time the pattern is the same. A wave of unrelated outages, a few hours of confusion, and then a quiet technical note from a company the public has never heard of, explaining that a single bad configuration rippled outward faster than anyone could catch it. By the time the fix lands, the lesson has already been delivered. Far more of the internet leans on far fewer companies than almost anyone assumes. The layer you never see. When you type an address and a page appears, it feels like you reached out across the world and touched a specific computer somewhere. That picture is decades out of date. For most of the popular web, you never get anywhere near the original machine that owns the site. Instead, you talk to something much closer, a server sitting in your own city or one a short hop away, holding a recent copy of the page. That nearby server is part of a content delivery network, and it is the thing most of the modern web actually runs on. The trick works because most of what a website sends you does not change from one visitor to the next. The logo is the same for everyone. The layout is the same, the fonts are the same, the background video is the same. There is no reason to drag those identical files across the planet for every single person who shows up. You stage them once, close to where the people are, and serve them from there. What a content delivery network is. A content delivery network is a global mesh of servers whose entire job is to keep copies of websites close to the people who want them. These copies live on machines called edge servers, scattered across hundreds of cities, plugged directly into the local internet. When you request a page, you are quietly routed to the nearest edge server instead of the distant origin. If it already holds the file you asked for, it hands it straight back. The original server, which might be on another continent, is never even bothered. Why distance is the enemy? The reason this exists is simple physics. Data moves fast, but not instantly, and every 1,000 miles adds delay. A request that has to cross an ocean and come back can feel sluggish no matter how powerful the machine on the far end is. Caching a copy nearby collapses that distance. The page that used to take a noticeable beat to arrive now appears almost the instant you ask for it. Multiply that across every image, script and font on a modern site, and the difference between near and far is the difference between fast and broken. Caching. In plain terms, caching just means keeping a ready-made copy of something, so you do not have to fetch it from scratch every time. The edge server keeps the logo, the styling, the images, the video, all the heavy pieces that rarely change. The first person in a city to ask for a page might trigger the edge server to pull a fresh copy from the origin. Everyone after them gets that stored copy at local speed. One trip to the faraway machine ends up serving thousands of nearby visitors. The network also has to know when a copy has gone stale. If the site updates its homepage, the old cached version needs to expire so people stop seeing yesterday's news. So every cached file carries quiet rules about how long it can be trusted before the edge server checks back with the origin. Most of the time you never notice this happening. A fresh copy slides in behind the old one, and the page you load is current without you ever knowing a swap took place. Absorbing the spikes. Speed is only half of it. The other half is surviving sudden brutal surges of traffic. A product launch, a breaking news story, a viral video. All of these can send more visitors in a minute than a site normally sees in a month. A single origin server would simply fall over under that weight, spread across thousands of edge servers around the world. The same flood becomes survivable. Each edge node handles its own slice of the crowd, and the origin barely notices the storm happening out at the edges. Standing in front of attacks, the same shape that absorbs a traffic spike also absorbs an attack. When someone tries to knock a site offline by drowning it in junk requests, that flood hits the content delivery network first, not the real server behind it. With capacity spread across hundreds of locations, the network can soak up an enormous amount of hostile traffic and filter out the obvious garbage before it ever reaches the origin. The site behind it stays standing, often without its owner ever seeing the wave that broke against the wall in front of them. Routing the world to the right door, there is a clever piece underneath all of this that decides which edge server you actually reach. When your device looks up a site's address, the answer it gets back is not fixed. It depends on where you are sitting at that moment. Fernathan, a Tikeo, and a Vern in London can request the exact same site and be quietly handed two completely different servers, each one close to them. The network is constantly steering each visitor toward the nearest healthy location. If one city's servers are overloaded or down, traffic is nudged to the next best place without anyone noticing the redirection. You think you reached the site. Really, the site reached out and met you halfway at whatever door happened to be closest. More than just storage, it is easy to picture a content delivery network as a giant warehouse of copies, and at the start that is mostly what it was, but the role has crept outward over the years. These networks now do far more than handbag stored files. Many of them inspect every request as it arrives, deciding in real time whether it looks like a real person or an automated flood. They can run small pieces of logic right there at the edge, reshape images on the fly, and block known bad actors before a request travels any further. The layer that began as a shortcut for speed has quietly become the place where a lot of the web's security decisions actually get made. The handful that run it, here is where it gets strange. Building this kind of global network is brutally expensive and brutally hard. You need real estate in hundreds of cities, deals with local networks, and a staff that can run all of it without sleeping, so almost nobody does it themselves. Instead, a huge share of the entire web rents space behind the same small group of providers. A few names you might know, like Cloudflare, Akamai, Fastly, and the big cloud arms of Amazon and Google, sit in front of a staggering portion of all the websites you use. For a site owner, the appeal is obvious. You flip a switch, point your domain at one of these networks, and overnight your little server inherits a global footprint it could never have built alone. Suddenly, your site is fast in countries you have never visited and tough enough to shrug off attacks you will never see. It costs a fraction of doing it yourself, and for most people, it is simply the sensible choice. The result is millions of those sensible individual choices stacking up into something nobody planned. Concentration without a logo. Think about what that means. Millions of independent sites, run by people who have never met and never coordinated, all quietly funnel their traffic through the same few companies. Those companies are not on the front of the page. Their logo is not in the corner. You would never know they were there. It is one of the largest concentrations of power on the internet, and it is almost completely invisible to the people relying on it. The web feels like a sprawling, decentralized place. Underneath, a surprising amount of it leans on a very short list of providers. When one of them stumbles, this is why a single bad afternoon can feel like the whole internet breaking. If one of these providers pushes a broken change or has a serious outage, every site sitting behind it goes dark at the same moment. To a normal person, it looks like chaos with no explanations. A dozen unrelated apps fail together. The bank, the airline, the smart doorbell, the food order, all stuttering in unison. The common thread is not visible from the outside, because the company they all share was never something the public was meant to notice. The cost of a shared wall. None of this means these companies are careless. Running infrastructure at this scale is genuinely hard, and the people doing it are very good at it. The issue is structural, not personal. When so much of the web depends on the same few walls, those walls become single points of failure for things that were never supposed to be connected. A mistake that would once have taken down one website can now ripple across a meaningful slice of the internet in seconds. The strength that absorbs attacks is the same strength that, on a bad day, concentrates the damage. Inside the encrypted path, there is a deeper part of this that most people never think about. To do its job, a content delivery network has to actually handle your traffic, not just pass it along blind, and most of that traffic is encrypted. So to serve and protect the site, the provider usually sits inside the encrypted connection itself. The lock icon in your browser often represents a secure link to the edge server, not all the way to the origins. The network unlocks the request, does its work, and locks it again on the way to the real server behind it. This is not a flaw or a backdoor. It is the only way the network can do half the things people rely on it for. You cannot filter an attack, you cannot read, you cannot cache a page, you cannot open. To sit usefully between the visitor and the site, the provider has to be allowed inside the conversation, which means the encryption protects you from everyone except the company in the middle. What that position can see, sitting in that spot is enormously useful and quietly powerful. To filter attacks and cache the right things, the provider can see a great deal about the traffic flowing through it. Which sites are busy, where the visitors are coming from, what is being requested, and how it all behaves. This is not framed as spying, and for these companies it is simply the cost of doing the work. But it is worth understanding plainly. A small number of firms occupy a privileged seat inside a huge fraction of the world's web traffic, in a position to observe patterns almost nobody else can. Trust you never agreed to. When you load a site, you are extending a quiet kind of trust to a company you did not choose and probably cannot name. The site's owner picked them. You simply inherit that decision every time you visit. That is not inherently sinister. It is just the shape of the modern web. But it is a long way from the picture most people carry in their heads, where they imagine a direct line between their device and the site they wanted, the giants holding it up. So the strange truth is this. A few companies most people have never heard of are quietly holding a large part of the internet upright. They make it fast, they keep it standing under attack, and they sit inside the encrypted path of a remarkable share of all the traffic that flows. They are invisible by design, named on no page you visit, and yet the modern web would buckle without them. The next time half the internet seems to break at once, it is usually not the internet at all. It is one of these giants, having a bad afternoon, in front of more of the world than anyone realized. If this is the kind of thing you find yourself thinking about, the internet underneath the internet, then this channel is for you. Subscribe and follow the rabbit hole with us, because almost every system you touch online has a hidden layer like this one, holding it up out of sight. Next time we look at the attacks these networks are built to survive. How a denial of service attack actually works. Why one machine flooding a site looks nothing like a million coordinated ones. And how the internet quietly absorbs floods that should, by all logic, take it down. That is the next stop down the rabbit hole.